Vielen Dank, Torben. Ja. Dann mache ich jetzt mal einen harten Switch rüber auf Englisch. Wer Probleme hat, irgendwas zu verstehen, kann mich nach dem Talk gerne auf Deutsch dann fragen dazu. All right, so today I want to talk about cross-platform testing and specifically what on earth do we have to buy? So how many devices do we need? Do I have to get like 100 smartphones and 5 different PCs? We'll try to answer this today. So, and we want to go low budget. We're indies, we don't have much money. So, first thing we'll be talking about are the platform differences. Like, what are we looking at? Like, what do we have to pay attention for when we're making our shopping list? And last but not least, we'll have 2 shopping lists. One is a minimum budget shopping list. We'll try to go as cheap as possible while still having like a 95% range of hardware that we have to test. And that'll come in different varieties, like for desktop, mobile, consoles. And then one with a recommended budget that's a bit more expensive, but will get you a much better coverage. So first off, platform differences. First of all, middleware compatibility, that's always a thing you have to pay attention to. What platforms does your engine support? One caveat is, for example, that Unreal Engine does not support cross-platform compilation very well. So on Windows, you can build Windows and Linux, but you need an actual Mac to make a Mac version, which is weird. And it gets even worse that you need an M1 Mac to make an M1 Mac version and an Intel Mac to make an Intel Mac version. So that can get very complicated. So always make sure that your engine has the tools and capabilities for your system, and so you can define your target platform. Then next up, engine features. Unity HD rendering pipeline does not support mobile. I think Switch also has problems with it. Always be aware of that. Code assets. Just go for avoiding DLL files, for example, which are Windows only, unless you actually are targeting this only for Windows. For example, the Steam SDK, if that's native for Windows, mobile, and Linux, that's okay. But you don't want to have your video middleware just for Windows, Mac, Linux, because then if you want to do a Switch port, now we need a different middleware for videos, and we'll just throw away a bunch of code. Yeah. Middleware also goes for stuff like Wise, Fmod, so always pay attention. If you get any assets, any extra middleware, what platforms do they support? Video and audio codecs, I just said that. Always check any dependencies of any kind for platform support. And graphics APIs. Many engines like Unreal and Unity, they have their native way of writing shaders and stuff, but for Unity, for example, you can write OpenGL shaders. These just won't work on specific consoles, or they won't work on Mac and stuff like that. So that's also something to be aware of. Yeah. Then, platform-specific features. Achievements, leaderboards, multiplayer. These are all things you want to abstract. So just go annoy your developers and tell them that they have to do that. Because later on, you don't want to like tear out the Steam SDK and replace it with the Google Play Game Services or Xbox Live or something. But yeah, so they should be prepared for that. And now, let's get to hardware. Aspect ratios and screen sizes. So basically, screens are maybe a little nightmare for many developers because they come in many different shapes and sizes. We have 4:3 aspect ratios like old school monitors or the iPad. And it goes all the way up to like 21:9 for widescreen monitors and smartphones, but then we also have like ultra-wide displays with 32:9 or something, so it's like ultra-wide. Just make sure your game doesn't crash on those things and that you know how they behave. Yeah, so I definitely recommend testing on 4:3, 16:9, 16:10, 21:9, 32:9. These sheets will be provided on the Indie Treff website as a PDF, so you don't have to write something down or something. And usually your engine will give you the possibilities to just resize the aspect ratio of your in-engine testing, so you can just verify how your UI behaves. Then, resolutions. Full HD is, of course, the most prominent nowadays still. Then we got 4K for high resolution, so that's very important to test because maybe your text becomes all blurry on 4K. That's horrible for a strategy game with lots of text. Then Steam Deck has a very low resolution, so that gives you the opposite problem. Maybe your font looks too blocky to read or something. Then the screen size. We have anything from 4 inches to 40 plus inches on TVs. So your UI must be scalable in some way. You just need to see, okay, for mobile, we'll use that. For TV, we'll use that. There are many solutions to that. And then, favorite thing for Apple users especially, notches. People just woke up someday and said, hey, you know what this screen is missing? A hole. And then they just poked holes into screens, and now like, on the very bottom here, you see iPhone screens. They have that little notch in there. The new MacBooks even have them. Safe area is the keyword you want to Google there, because most engines, such as Unity, support it. And you can just ask the device, hey, what's my safe area? And it will tell you this area is safe to use. So just make sure your UI is there, and not that the close this ad button is under a cardboard cutout on some Android so people cannot close the ad. Then, file systems. Desktop. Windows is case insensitive, and you have something like C users dude. Mac OS, case insensitive, but now it's / users / dude. Linux, now they're case sensitive and have /home dude. So they differ greatly, so we definitely want to test on Windows, Mac, and Linux, especially if you have file access in some way. Most engines will offer you ways to access the file system in an abstract way. Now, mobile gets interesting and interesting. Android and iOS are case sensitive. File system access is very limited on mobile, but it's possible. And luckily, Windows Phone is dead because Windows Phone was very, very special. Now, consoles, it's similar to mobile systems, mobile file systems, but everything is under NDA, so good luck Googling that. I have seen a few console systems, and my pro tip is support Apple TV. I don't care if you like this thing, if you want to develop for it, if you want to release for it or not, buy one, develop for it, make sure it runs, and then throw away the Apple TV. I don't care, because the Apple TV is the most limited file system access you have. 0, none. You cannot save a single JSON file on an Apple TV. So if you support that thing and a desktop and mobile, you'll support anything a console throws at you. Now, GPU vendors. Now things get really fun. So here you see a bunch of different vendors. All of them like to do things a little bit different in their specific way, how they think is best. And you also see desktop, mobile, and consoles. Where will you find which? So for desktop, we have to test our game on NVIDIA, AMD, Intel, and Apple to make sure it works on all systems. On mobile, you have even more different varieties. And consoles, you got NVIDIA, AMD, and proprietary stuff. So in a perfect world, we want at least one device from every vendor. We'll see how we'll do that. Controllers, lots and lots of fun. Come in many different shapes and sizes. And the favorite fact is that you have these different glyphs on the buttons. So sometimes the south button is A for Xbox. On Nintendo, it's B, and your confirm button is to the east. And PlayStation just has X and O. And luckily now X is confirm in the newest PlayStation generation, so you don't have to check the region to say, okay, in this region O is confirm, and in the other region X is confirm. So that got a bit easier. And yeah, many platforms also demand that you actually use their glyphs. So if you have glyphs that almost look like the PlayStation glyphs, but you're like maybe showing the start button glyph that was on the PlayStation 4 controller, then you will not make the certification for PlayStation 5. So you have to be able to detect which controller is being used and show the correct glyphs. So these are a bunch of controllers, including Steam Deck, and there's a little life hack here. This thing is probably my favorite piece of hardware. This is a controller by 8-bit Do. It's called the Pro 2. And this has a neat little feature that when you power it on, you have to tell it power on in PlayStation mode, Switch mode, or Xbox mode. So this actually emulates 3 different controllers for the price of one. It's always next to my desk when I'm developing anything. And so yeah, just pay $50, test 3 different controllers. Other hardware. VR, I don't know really, but you have different input controllers, you have standalone versus desktop systems, so can't say much about that. Keyboards, on the other hand, oh boy. We have QWERTZ and QWERTY, but my recommendation is definitely get a French keyboard because it'll mess you up. It's AZERTY, and if your game, for example, with WASD controls works on a French keyboard, it'll most likely work on many other keyboards as well. So you always want to go by key location and not the character that's being pressed. Then pointer devices, mouse, trackpad, touchscreen, pen. It's relatively easy to get the ones covered that you need. It's usually going to be mouse, trackpad, and touchscreen. And for storage, SSDs versus hard drives, only relevant for open world games, and let's be honest, even an indie open world game won't be too affected by it. CPU, we don't have to pay much attention. The engines all take care of it. If you're developing something from scratch in C, good luck, have fun. But yeah, also memory, we don't care what type of memory we're using. So what do we need? Possible operating systems: Windows, Mac, Linux, Android, iOS, Apple TV uses tvOS, and we got Fire TV for Amazon Fire TV. Consoles in many forms, shapes, and sizes. GPU vendors: NVIDIA, AMD, Intel, Apple. Other controllers: Steam Deck, Xbox, DualShock with the PS4 controller, DualSense for PS5, and the Switch controller. And screens, basically 720p, Full HD, and 4K. We got basically 4 different size categories: phone and tablet, monitor and TV. Especially monitor and TV, you always got to pay attention with distance. Some UI becomes harder to read or not. And notches. And yeah, as I said earlier, get a cheap French keyboard. But now, how do we get all that stuff into a shopping list? This first one will be the minimal shopping list. So this is if you're developing for desktop first, mobile and consoles later. First of all, remember, you do not have to own this stuff. You just have to have access to these devices. So use your friends, use your family. And you already have at least one device if you are developing, hopefully. Exceptions to this rule are, if you're supporting controllers, you want to have at least 2 different controllers. As I said earlier, you can fake that with that one cheap controller that I showed you. And if you're really supporting mobile, then you most likely want to have access to more than 1 Android and 1 iOS device. So, first off, we'll be starting this list with a Samsung A14. So first up, one small note. I am always using very modern hardware. So I'm rather going for the cheapest, low-end, but modern devices so that they actually last a while. Because we're indies, we don't have much money. If I'm going to buy this Samsung phone, I might as well want to be using it for something. And if I buy a Samsung, for example, from 2017, that didn't get any updates, yeah, all Android phones that didn't get updates since 2017 can just be hacked by Bluetooth without confirmation. So you might want to avoid that stuff. So always use current devices. So why do we go for the 814? We got Android, a portrait mode, we got a notch in there, and it costs only 130 euros. It's got a weak CPU and a weak GPU, which for me is a plus. I want to see if my game, how does my game perform on a weak mobile phone? I know it'll run on the newest iPhone. That's not the interesting question. And it's a popular vendor, so if it works on a Samsung GPU, they have a specific vendor that they always use, the GPU vendor. So that'll most likely work on like 50% of all Androids now. Next up, the iPad. 8th generation. So that's not this generation, it's not the last one, it's the one before that. It'll probably still get security updates for another 6 years. And it's got iOS, 4:3 screen resolution, average performance, and I definitely recommend getting 128 gigs because I have the 64 gigs one. I have to remove apps every single time an OS update comes out. It'll drive you crazy. So that's 320 euros. That's a used price there. Mac Mini M1, 8 gigs of RAM. This is the absolute minimum that I recommend for a Mac. You can get much cheaper older Macs, but they aren't very strong. And this one gives you macOS, a seriously powerful CPU. So chances are, if you're developing on a laptop, a Windows laptop that's like 2 years old, even if it's a gaming laptop, chances are this CPU might be just stronger than your current one for development. And it gives you an Apple GPU, one of those newer ones. So that's another platform. Then we have the Steam Deck. For 300 euros, I recommend getting the very smallest one because the SD cards, they have super loading times. I don't notice any difference between internal storage and SD cards. It gives you the second desktop operating system, Linux. You have an AMD GPU, so now you have Apple and AMD. You have a low resolution, a small screen, a unique controller, and oh my god, is debugging easy on this machine. Next up is a notebook. Intel with an included integrated GPU, and for example, an NVIDIA 1050. This thing will get you can come across it for like around about 500 euros refurbished. And it gives you Windows, so the last operating system, and the last 2 GPU vendors. Now again, you already have a device that you're programming on. It might be a Linux machine, might be a Windows machine with AMD. So just see that you get these checkboxes done. Then I recommend the Samsung U28 4K monitor if you do not have a 4K monitor yet. It gets the job done, has 4K resolution, it's only 200 euros, and yeah, you use it for text and UI scaling. Then there's an Acer Chromebook 315. It's cheap 250 euros Chromebook, so it gives you Chrome OS. This thing lets you test x86 Linux builds and x86 Android builds. So that's what Chrome OS just uses. It has an Intel integrated GPU and a very weak CPU and GPU. So especially if you're running 2D games, it's very interesting to see how your game runs there. If you have a 3D game, this thing will not cut it. Do not buy it. Have a look at the recommended list. Then, of course, the cheap controller that I recommended earlier, and the Apple TV 4K 3rd generation, 160 euros. The older generations are still supported, but they cost the same, so And this gives you TV OS and no file system access, so that will be the best testing platform if you want to support consoles later. All in all, we are at 2,380 euros. Again, minus whatever you or your friends may already have. So this is just a list. I hope that you can already check half of these boxes and then maybe see, okay, I need to buy these 3 things. Next up, we got a list for desktop first, consoles later. So here I just removed the mobile platforms. Then we're left with 1,680 euros, but especially this. And this is just very good if you release a game on Steam and you think like, okay, console development is too expensive right now, but if this is a success, then I want the possibility to port it to consoles without having a massive development budget. Then this is for you. And next up, desktop only. Notice how we only saved 150 euros. So it's not that much difference. And last but not least, here is my recommended shopping list for all systems. I don't know how well you can see it. The bold texts are things that changed. So for one, I would recommend going for the Mac Mini M1 with 16 gigs of RAM. Because, for example, if you're running Unreal Engine 5, this Mac Mini will easily run the Unreal Engine with the full editor and everything. And you can use this thing as a development machine. You can use it for anything you want. So with 16 gigs of RAM, you can actually have a very, very potent computer. With 8 gigs of RAM, you have a very strong CPU and not enough RAM. So then the Acer Chromebook. This is an upgrade that comes up from 250 euros to 560. But the big thing here is that this thing has official support for the Steam beta for Chrome OS. The other machine also supports Steam in some way, but it's not officially supported. And this is a Chromebook that might be able to run most 3D games. With Unreal Engine 5, I'm not sure if it could handle that, so it's just got an Intel i3 integrated GPU, so you'll have to research that beforehand. Yeah, the serial number here is very important, so I wrote it down, the CB5152H. And on the very bottom, another thing I add is that you actually get one of each current generation controller. So that's from the Xbox, the newest one, the DualShock and DualSense, because Steam recommends actually that you add support for both PS4 and PS5 controllers, and a Switch Pro controller. And that together with the 8-bit Do Pro 2 controller, then you can just test any combinations that you might have for controllers. And this recommended list will set you back 3,200 euros if you have 0 friends and family, and you also do not have a single device that you're developing on yet. So yeah, for me personally, in total, it was an investment of like 1,000 euros, a little bit more to actually be able to support everything. And again, here we have everything to test for Windows, Mac, Linux, Android, iOS. We have every single major GPU vendor here. So if you test on these devices and your game runs, chances are very slim that people will say, hey, your game doesn't run on AMD graphics cards, or hey, my Samsung phone doesn't render your game. Yeah. And this is my last slide. So thank you very much, and I hope that wasn't too much. All right, questions? Microphone is coming.
So I have 2 different questions.
Mm-hmm.
The first one would be in the context of developing for Linux.
Yes.
Now, especially with the Steam Deck and SteamOS and everything, and how Proton is used, there are a lot of games that basically just gamble on Proton just doing the heavy lifting. So what are your considerations on developing specifically for Linux versus just developing for Windows and trying to iron out whatever problems arise with Proton?
All right, thank you very much. So in general, I would say the more complex your game is, the more likely you want to have native Linux support, because of all the moving parts. But Proton has gotten really, really good. So the last 2 games that I developed have native Linux support, but they both run out of the box perfectly fine on Proton. So I would recommend, if you have Linux know-how, support Linux directly. If you do not, it's totally fine to just support the Proton way.
All right, thank you. My second question would be in the context of the Apple TV. So you elaborated on how it doesn't have any file access. My question would be how, if at all, are save files handled at all?
Yes. So save files on the Apple TV are generally handled by using, it's something like the Windows registry. So Apple has these plist files, and that's the only way that you can serialize data there. So you would basically serialize your data into basically a registry entry, and that can be set up to synchronize via the Apple Cloud, also with iOS devices, for example. So there you basically have to write a persistence handler in some form that just gets your save data and then checks the file operating system and then decides, okay, I'm writing this save data to, for example, if you're using Unity, you use the player preferences. If you save into that, it will automatically land in this registry. And Unreal has something like that, so you have your access to this sort of file system or file storage in your engine. So you just have to abstract and then check if you have a file system or not.
Okay, thank you.
You're welcome. Yeah, back there's a question. I'm sorry, could you come a bit closer?
So you mentioned these platforms, which besides the Apple TV are pretty open. What about like, because you mentioned like PlayStation and Xbox controllers. So there's probably like an application process to get your app tested there, right? Because you can't just, well, I know it's easier on Xbox, but I heard that you can't just deploy like an app on a Switch on PlayStation.
Yeah, that's regarding the dev kits specifically, right?
Yeah.
Yeah. So getting the dev kits is step 2 after you've developed a game. I would first of all recommend first releasing on desktop if you don't already have a publisher or something, because it's much easier if you have a successful game on Steam to then approach a console manufacturer and like, hey, Nintendo, I would please like to publish this game. It already has 1,000 positive reviews on Steam. So this shopping list here with the test devices, if you're already supporting an NVIDIA GPU, which you'll find on the Switch, different controller types, and you have not locked yourself into any middleware that does not support Switch, and you also are able to support anything from Apple TV to mobile to desktop, then you will encounter very few things that you actually really have to adapt apart from performance issues on the Switch, for example, to actually support it. So this goal is to have a cross-platform project that is as dirt cheap to port as possible.
Okay, so are the like you mentioned dev kits? Are these like separate things you get from the console manufacturer, or could you like use your friend's PlayStation and like create a dev account on that?
In general, no. I always recommend a dev kit. On Xbox, there is a way to somehow get your game onto an Xbox, but the binary that you build there is completely different than what you are building if you're natively supporting Xbox. So it won't tell you too much. And if you support a Windows PC with an Xbox controller, you're already halfway there. So that's why I recommend supporting the different controller types. And then you definitely have to apply at the console vendor, like, hey, Nintendo, I would like to publish this game. And then they say yes or no. And then you get the process rolling. And I cannot tell you anything apart after that step.
All right, cheers.
All right, thank you. All right. Looks like that's it. Then happy shopping, I guess, and happy developing. And I'll pass it over to Torben.